Good afternoon, good morning, everyone. Welcome to Peer Group's webinar. Our topic today is gRPC, What You Need to Know. Maybe a presumptuous title, but we'll go through it and hopefully tell you guys what you'd like to know or what's important to find out. My name is Doug Zurich. I'm the Director of Marketing here at Peer Group. I'll be joined by Albert Fujigami, our Semi-Standards Committee member and all-around guru on various standards, particularly in the DDA world. And with that, we're going to jump right in. So what I'd like to do, just as we get started here, if I can find my window, there we go, just a quick poll just to get a feel for what kind of languages everyone here is using, what you're aware of. This will just help us fine-tune the presentation a little bit and figure out how we can best describe some of the advantages of gRPC to you. Here at Peer Group, we're pretty excited about gRPC. This is something that we've been looking at for a number of years. We've brought it forward to the semi-standards organizations, getting involved in some of the semi-standards that Albert's going to talk about, as well as making pretty extensive use of it internally inside our next generation products, which is all something we'll talk about as we go through the session here a little bit. We do actually have a pretty good crowd here, so I'm glad you guys are joining us. A couple housekeeping items while you guys are going through the poll. We will be recording the presentation here today in the webinar. Everyone who's registered will get a copy of that link in a few days once we've had a chance to clean up the video a little bit. And we do encourage you to participate inside the presentation today. So you should see on your screen a questions and answers box. Feel free to put any questions in there. We'll take the time to address some of them at the end of the presentation today. And anything we don't address live on air here, we'll make sure to follow up with you one-on-one to get your questions answered. So feel free to take advantage of that. All right, let's share our responses here. Pretty good variety. So perhaps as expected, maybe with Peer Group's audience here, a lot of C#, a lot of Microsoft people, a lot of people using C, C++, and then Java and Python and a bunch of others, and maybe I don't know's coming through. So a wide variety of programming languages going into our factories and our tools and in the semiconductor world. And honestly, that is exactly where we come in with our gRPC, the requirements and why it exists. So let's dive right in. Taking a look at what a software architecture is and how we've built up over several decades of computer science. If we take a look at what the simplest software program application is, we've got a monolithic architecture. So this is the very basic thing. This is how software started. This is what everyone learns when they first start to school. You've got one blob of code running at everything. So your user interface, your process control, your communication, all of it's inside one block of code. You wrote the code yourself. It's one big architecture. Now, obviously, fairly early on inside computer science development, we realized that's not the best way to go. You want to start splitting things out, taking advantage and reusing code from elsewhere. So often what you'd see is starting to take advantage of embedded libraries. And this is, if you'll let me stretch the definition a little bit, the first time we start to see remote procedure calls. But because these libraries are inside our code, it's not remote at all, it's in process. It's almost like we're making calls into our own code, but what we've done is we've got some libraries that are taking advantage of certain things for us. So on the screen here, our SexGem communication, we might be using a library for that, and then any kind of data storage technology. We can use a library for that. The rest of our code lives inside that one process, but we're still talking about one software application running on one computer. Moving forward, another generation, we certainly started to see the need and the advantages of running multiple programs, in this case on the same computer. They're all talking to each other and all specializing in different functionality. And the little triangles you see on your screen here is where we start getting into some of the, really what a remote procedure call is, an out-of-process call. So if I've got my application, my tool control software, my MES, what have you, and I want to talk to a piece of software, Peer Group's EIB, that's handling the host communication or some of the equipment conversations, those two programs need to talk to each other. And this is where we have to start making some decisions about what technology we'll use to talk between those different applications. Another good example is a database. It's oversimplifying perhaps to think that a database's primary job is to write to disk or write to storage. But if you really boil it down, that's what it does. And what we're doing is we're outsourcing the requirement to write to disk and read from it and pull our data to another program. So how are these guys going to talk to each other? When we get to the, really the modern generation of software architecture, it gets even more complicated because very often these different programs are running on different physical machines or virtual machines. So your database, very often, your SQL Server is going to run on a different computer, and we're going to be talking to it. So inside my program, I've got to try and talk to SQL Server. Again, EIB could be running on the same computer, could be running elsewhere. And maybe not surprisingly, SexGem is itself a remote procedure call type technology that's going to allow our local tool to talk up to the host systems or the factory systems inside the factory. So this is an example of a distributed computing type architecture. Our different pieces of software scattered around the factory across different machines, potentially up in the cloud. And we got to fill in those triangles. We got to find a way that we're actually going to communicate between these different software packages. So remote procedure calls, RPC. What makes a good RPC? Well, certainly you can see the list here. We want it to be fast. We want it to be flexible. More and more, and you saw it in our poll up front where we've got all these different software languages. We do want to be able to talk across different languages, different platforms. So if I'm running Windows on the tool and Linux or something else up at the host level systems or for the database or the MES, I want to talk across those different platforms without having to worry about it. Stability, obviously super critical. Ideally, our RPC software will have the ability to choose between synchronous, so I'll make a request of the database and I'll sit there and wait for the answer to come back, or asynchronous, I'll make the request, go do some other work, and then be informed when the results are ready. So ideally, I'd like the option to go back and forth between those two. And this one I put a star on at the bottom is for local and remote support. Certainly from a simplicity standpoint, you think, okay, it would be good to use an RPC technology that worked on one computer or can talk across multiple computers inside a factory or can talk up to the cloud. It's great from a simplicity standpoint. It's great from a flexibility standpoint. You could change your deployment in your architecture by having one RPC framework. The gotcha there is that you're optimizing for nothing. These are the all season tires type approach. So whatever protocol I use that might be great for talking across the network might not take advantage of certain things that can happen locally, and vice versa. Communication protocol, remote procedure call that works locally, yeah, maybe I can make it work remotely, but it's not going to be necessarily perfect. So it depends what you're looking for there. You can trade off simplicity for maximum optimizations. Jumping right ahead, what is gRPC? What are we talking about here today? Well, originally known as the Google Remote Procedure Call. Some people have tried to rename it as the Good Remote Procedure Call. That really hasn't clicked on. The Google name is strong. However, Google no longer owns this protocol. So they invented the protocol, but very early on, they donated it in 2016, I believe, to the Cloud Native Computing Foundation. So they started it, they got it off the ground, but now it's owned and managed by an open source, not-for-profit Cloud Native Computing Foundation. The core principles of gRPC, so why this is a next generation remote procedure call framework, the big one really comes into it, kind of the combination of this services, not objects, and messages, not references. So a lot of the early remote procedure call frameworks, they tried to get to that idea that I sort of hinted at, where whatever I'm calling locally, object-oriented programming, I've got an object that says get data from disk. Well, if I was really clever, I could change the guts of that so it's running somewhere else, but my program thinks it's talking locally, even though it happens to be somewhere else. So I'm calling an object, my data storage object, my host object, what have you. And I don't have to know whether it's local or remote. While you're sitting there doing the coding, that sounds great. It certainly makes it easier, but it leads to a lot of bad patterns. It can lead to some, simplest, if my code is running locally, I can make 1,000 calls to it. It's going to be very quick. If my code is running remotely, I'd rather bunch up those calls, make one big call and bring it back again. So if my application isn't aware of local versus remote, if I hide the network, I'm not going to necessarily get very good performance. So gRPC right off the bat says, we are not going to hide the network. Honestly, it sort of assumes that everything's over a network, even though it can and does run very well locally. But it's going to force the developers to understand up front that they are running in that kind of environment. They're going to choose better decisions to make better performance, and you're going to handle your error situations a lot better. Also, gRPC is trying to look at overall coverage, a bunch of different scenarios and a bunch of different options that gives you the flexibility to deploy it in a bunch of different areas, different types of remote procedure calls, while at the same time being very simple. Those two can be in conflict, but they've done a fairly good job. So if we look at gRPC versus some other protocols that you're probably currently using, whether you know it or not, a big one, been there forever, is SOAP/XML. Somewhat famously, SOAP is much more on that object side where it tried to hide things from you, and it got fairly complex fairly quickly. So it started out not too bad, and then it got very big and very hard to work with. And so a lot of people have struggled, particularly trying to debug issues with SOAP communication. Microsoft came out with the Windows Communication Foundation, WCF, big part of the .NET framework for 4 major generations, probably close to 20 years. Originally, and certainly spec'd out, that WCF was supposed to work in every environment, not just Windows, could work on Linux, could talk to other programs. Never really caught on. Yes, there's support for it on Linux. Yes, you can get it to it from C, C++, there's Python libraries, but realistically, nobody trusted Microsoft, so they didn't really trust Microsoft to keep that clean and pure. So they didn't really adopt it outside of the Windows world. In the Windows world, extremely popular, very powerful, reasonably flexible, a lot of different ways to configure it, but didn't really get outside that .NET world. One of the great things about gRPC, again, it was kind of built for the modern internet age, the modern big data age. A lot of the early RPC frameworks were unary methods. I make one call, I get one blob of data back. To get more data, make another call, get another blob of data back. gRPC has built in a streaming ability. Any kind of data collection from the factory, you're going to want to do that. You're going to want to tell the tool or the equipment or the software on the far side, send me all the data you can as soon as it's available, and that data is going to come across in a stream that we can manipulate and handle, but we're going to be able to get that continuous feed of new data as opposed to having to pull for it over and over again. And another thing, and this comes from again, Google's original purpose and the fact that it's going to run over the open internet, has built-in security, has built-in ability to leverage common standard protocols. TLS is what your bank uses when you go over the website to do your banking. It takes advantage of all those things to encrypt the communication channel. A lot of our factories do not bother to encrypt the communication channel. Those of you who heard me talk for a few years know that I've been fighting the good fight, trying to encourage people that even within our factories, we need to start thinking about security, create more layers of security. Don't necessarily trust that just because you're inside the factory environment, you don't need to encrypt everything and things can be in the open. We should be thinking about making sure that all of these important communication channels are protected in multiple layers. The ability to encrypt this using very well understood technology, certificate mechanisms that most IT departments understand very well is quite convenient. I'm not going to go through this whole chart here, but the quick takeaway is that, my goodness, gRPC is supported in a lot of environments. And unlike WCF, where it's sort of supported kind of on the sly, this is frontline, main level support from all the major manufacturers, all the major programming languages, anywhere you want to be able to use it. This is supported. An adjacent technology to gRPC, you might have heard of protocol buffers, and this is worth digging into a little bit. It's a different piece of technology, but it's very important, and really this feeds into a lot of where the efficiency comes from of gRPC, as well as how we get this cross-platform support. So in a SOAP XML world, you can see my XML blob there, and I've encoded my name, an ID, and an email. Oftentimes, in a SOAP XML world, any kind of XML world, XML is great because it's self-describing. So you can look at that XML and you can see that, that first piece of information there is a name, because it says it's a name. And that's literally what goes across between the client and the server. So the nice thing is that the server doesn't necessarily need to know what's coming. It can get the message, pull it apart, find out all the details. The downside is you are sending that across every single time. That's going to take up more space. You can see it's 117 bytes here, unoptimized, but it's a big patch. Protocol buffers is a way to describe what these messages are going to be in a language neutral format. So you can see my person.proto there. Looks like code, but relatively simple code. I've got a name, an ID, and an email. The name is going to be in the first position, ID in the second position, email in the third position. That's the proto file. That's how it describes the interface. And then any programming language that's going to consume protocol buffers, consume gRPC, compiles that into its own description of how to use that. So you can get a C# protocol buffers compiler, will compile it down to what it wants to use, another for Python, for Ruby, for C++, what have you. The advantage there is that what goes across the wire is that bottom value there, the serialized value. which is only 35 bytes. And it's the exact same information that's in the XML. So it's Doug at 99 and then my email address. And then I can't remember exactly, I think it's only about 5 bytes of padding to show where the breakpoint is in between these things. So by doing that extra work up front with protocol buffers to specify what the message content is going to be, you get a much more efficient on the wire. So you get that 35 bytes instead of 117 bytes. It means it's not human readable. Certainly no one's going to look at that bottom thing and figure out what's going on, but you don't often care about that. So protocol buffers, not strictly speaking part of gRPC, the two of them work together to achieve what we want to do in this communication across the wire. So why choose gRPC? Why are we promoting it? Why a lot of others are promoting it? Certainly, like I said, it's very high performance. It uses that binary encoding on the wire. Great cross-language and cross-OS compatibility. Fairly mature libraries at this point doing that. And Google's using it, no surprise. Perhaps more of a surprise is that Microsoft is using it. So if Microsoft and Google are agreeing on something, you can imagine we're probably going in the right direction. And from a semiconductor standpoint, Semi has in the past perhaps been accused, but maybe it's because we got there first and had to do things on our own. Bit of a not invented here syndrome. That's certainly going away, and we are taking best practices wherever we can find them and leveraging them in our environments. So if the Googles and the Microsofts of the world have done a whole bunch of hard work to come up with a great remote procedure protocol, that works on the screen, like you say, between Android and Ruby and C++ and C#, then we should absolutely take advantage of that. Getting into the Microsoft side of things, so WCF was their remote procedure call framework of choice for a very long time. That, by and large, is being deprecated. Now, you will never find Microsoft writing a document that says, we are deprecating the following technologies. They just don't do that. What you do see is that it suddenly disappears from all the future versions. So .NET 4.7 was the last time that WCF showed up on the server side. They're now up at .NET 6. And when you look at the recommendations for .NET 5 or later, Microsoft is telling people to go with various gRPC technologies. So again, I looked long and hard to try and find a place where Microsoft would say, thou shalt do. That's not how they work, but they will recommend that it's time to move to gRPC. So with that, I'm going to flip this over to Albert Fujigami. Like I said, Albert Fujigami is a senior software developer here at Peer Group, extensively involved in the semi-standards community. He's the co-chair of the North America Diagnostic Data Acquisition Task Force, and he recently received an award from the Japan Information and Control Technical Committee for all of his support of these standards and many more. So Albert, why don't you take it away?
Great, thanks, Doug. Let's go with our next slide. So next couple slides here, I'll be talking about factory communications and where we see gRPC and where we see it being used and where it can be used. So this slide here shows all the protocols, or a good number of them, that we've been seeing on the factory floor, as well as the standards some of them are using. So you can see here the various protocols and the standards listed. Some standards are there to kind of identify how to organize the data and how you talk to each other, what the expected behavior is when you're sending messages back and forth. Others don't. So that means when you are using that protocol to talk to that piece of equipment, the factory and the supplier need to work out that behavior. And so even for the same supplier, there may be different tool types that have the different implementations. So now you need to build some custom code to talk to that piece of tool. And obviously that's going to be a little bit more effort. So when we talk about factory communications, a lot of the time we're talking about talking to the factory host or the MES. And you can see here on the diagram in the upper left-hand side, SexGEM and the GEM 300 standards are pretty well used in a lot of places, but there are still some situations where we run into some custom interfaces. Now, the other part is that all the people want to get data off of this equipment so that they can do some analysis or process it. And then you can see that here on the upper right-hand corner. A lot of different protocols that are being used that feed into some different equipment engineering components that do analysis, that do FTC and health monitoring. Now, SEMI has a couple of standards out there that are helping in this area. One is the EDA and Interface A standards. Right now, they're using SOAP XML technology, but we're looking at putting in gRPC and protocol buffers, and we'll talk about that in a couple of slides. We also have the new RIT-DB and TEM standards. These are geared towards the automated test environment and test cells. And we also have SEMI E133 that uses the SexGEMS infrastructure to basically have a standard way of talking to all these engineering, equipment engineering components together. Now, your equipment is also going to be talking to the factory infrastructure piece, and that's here on the bottom left-hand side there. So here, we've got standards like SEMI E84 that's going to let you talk to the automated material handling system, or the AMHS. And we also have standards like the SMT ELS that lets you talk to equipment that are right next to you, rather than having to send a message up to the factory host and then back down to that piece of equipment. And then finally, on the bottom right-hand corner, we've got external components that we talk to. So these may be devices that are connected to the physical tool, or they may be part of the subfab infrastructure. So when you look through the list of the protocols, you see on the right-hand side is a lot of the places where we see gRPC today. So mainly talking to the equipment engineering components and the external components. We don't see gRPC very much on the left-hand side, where we're talking to the factory, the host, the MES, or the equipment, the factory infrastructure. And that's mainly because these standards on the left-hand side, the needs are fairly well known and they're well established. Next slide, please. So when we're talking to a piece of equipment, it's generally for two main reasons. One is we want to control it. We want to tell the equipment to do something. And the other main reason is we want to get data off of it. So let's talk about the first one, the command and control part first. So here, SexGEM is mainly being used. It's well-established protocol and infrastructure. And in the short term, we don't really see gRPC coming in and impacting the command and control side of things. Now, we do see, though, gRPC could be incorporated if maybe one of the following features is required. So if there is a strong desire to secure the communication channel, so we want to use SSL TLS to encrypt the channel. We want to have authentication and authorization with the fab component. So today, with the SexGEM protocol, we're doing point-to-point communications. And that is a form of security, but that's not really appropriate in all the different scenarios that are out there. So if we want to secure the communication channel, that may be an area where gRPC could come in. Another area is we want faster communication. So SexGEM does allow you to have data collection and send the events up to the host, but because this channel is also used for control, we don't want to flood the channel and send a huge amount of data, so much so that we actually can't get any control messages, because that would be bad. And then finally, if there's a desire to use open technology. So if you have some equipment or devices that are coming from other industries, using something like gRPC would be a good fit, because it's not specific to semiconductor, whereas the SEX protocol is specific to the semiconductor industry. Now, this kind of a demand is going to be driven by the factory. So when they feel that there's demand for these kind of features, then I think we would look at incorporating gRPC into the standards for something like SEX and GEM. Now, one thing I do want to point out, though, is an area and opportunity is that if we have devices and equipments that don't talk SEX GEM today, but it does need some kind of control capability, then maybe we should look at gRPC. So, for example, if we need to design some kind of a lightweight command and control channel for subfab devices, that might be a good area. And it would be good because it would complement the work that we're doing with EDA Freeze 3. Next slide, please. So with EDA standards, as I mentioned, we're incorporating the gRPC technology as part of the Freeze 3 work. And we're doing that to get better and more efficient data transfers. So you can see here on the left-hand side, the diagram where we're swapping out the XML technology and putting in gRPC and protocol buffers. Now, when the DDA task force was investigating this a number of years ago on what kind of technology we should be using, peer group did a bunch of prototyping as our contribution to the task force investigation. And we found that when we were using gRPC and protocol buffers, similar way that we're using SOAP XML for data collection, we were seeing roughly 18 times better performance compared to the current technology. And even when you turned on securing the channel with SSL and TLS, now the performance obviously drops because you have to encrypt and decrypt the messages, but still, we're still seeing a significant performance. And you can see that in the chart on the right-hand side there. The other benefit of EDA is that it's a feature complete and it's a standard way of getting data off of the equipment and also to represent that equipment data. So you have a standard way of expressing the equipment metadata. So what kind of parameters, what kind of exceptions, what kind of events are available to collect off of the tool. You also have a standard way of collecting that data and managing that data. So there's a way to define collection plans. There's a way to specify how often you should be getting the data, how you should group the data, and then how it's all going to be sent out. So EDA can be a powerful way and a standard way of getting data off of the equipment, even if you don't happen to have high-speed data collection needs today. So at that point, I'll turn it back over to Doug, who'll continue on with the presentation. Thank you.
Thank you very much, Albert. That was great. So this comes down to the major questions, right? Well, how, and when are we going to implement gRPC inside our software? And, I spent some time on this slide and I was trying to break apart rules for the factory and rules for, on tool for our OEM customers. And really they come down to the same thing, which I guess is good. It shows that the same criteria is going in both ways. So sort of a three-part decision. So certainly if a standard exists, you want to use the standard. So Albert talked about EDA. We're big fans of EDA here. I think most of you probably know that. gRPC by itself, it defines at a fairly level, code geek, how things are going to happen, how data is going to get back and forth between two different software applications. But it doesn't describe what's going to happen on top of that. It doesn't put in behaviors in there. It doesn't actually define by itself what goes into those messages. Somebody else needs to define, using protocol buffers, et cetera, what those messages are, what's going to happen. That's where the standards come in. So that's where something like a SexGem comes in. Doesn't use gRPC under the covers, but SexGem does define messages and actions and everything else. That's where EDA comes in, but your ready standard that does use gRPC under the covers. So if you got access to a higher level standard that actually takes care of all the defining the details of what you need to do, that's what you want to use. And if it is a standard, by all means, don't write it yourself. Get a commercial product to do it. You don't want to be experts in these things. That is not the best use of the time for your engineers, your precious software development resources. So buy a commercial product that implements the standard and then do what you need to do by integrating with that. If you have an existing protocol, so if you have multiple software systems inside your factory or on your tool, they're already talking to each other, it's working well enough, you're not making massive changes to your data volumes, just use your existing systems. gRPC is better. I hope we've convinced you of that a little bit. It is the modern way to go. It is well supported. But if what is working for you already is working already, no need to change it. Even something like WCF that is being deprecated, Microsoft is pretty good at supporting that for a ways into the future. So it's probably not a great place to make an investment right now. On the flip side, if you are developing a new system, if you are going to a major change into your software systems, that's where you want to consider using gRPC and building your own protocols on top of that. Peer Group is taking this to heart. So Peer Group over the next several years, we are doing a major refactoring, a major rebuild of our core products. This is our next generation initiative, which you guys are going to hear more about soon, but today I could whisper about it a little bit. We are integrating gRPC into our entire software stack, top to bottom. So the way that our different systems are going to talk to each other, that's going to be over gRPC. The way that we're talking to our user interfaces, our new web UIs that are coming out, that's going to be over gRPC. That's going to be the plumbing under the covers. We truly do believe in this, and we've put a lot of investigation efforts into it and see it as the way forward. So for a company like Peer Group, where we are constantly reinventing our products, maybe not constantly, but we are reinventing our products, this is something that we're diving into. Overall, gRPC is a sensible option. Albert and I went back and forth in language for a bit. It's a good choice for any of your new deployments, and we are expecting it to increase everywhere. There are alternative remote procedural call frameworks out there, systems out there, even fairly modern ones, But everything taken into consideration, gRPC seems to be the winner because it really hits that middle level of functionality and usefulness and everything that people want to see. So we expect this to catch on in a lot of different environments. Because of that, you can expect it to continue to be supported in the future, continue to have those small changes and tweaks, and it is going to be something that we'll see inside our factories and inside the OEM software itself. With that, that's the quick flyby of what's going on inside the world of gRPC. I hope you found it useful. I hope you learned something. If you're interested in learning more, feel free to reach out to Albert or myself. You can catch us by email or jump in our LinkedIn profiles there, and we'd be happy to talk more about what's going on and some of the things we see coming in the world of gRPC. But I do thank you for paying attention to us here today.